Okay, first topic, basics, right? So basics are nothing but pre-calculus. In this pre-calculus, we are going to discuss about logarithms, trigonometry basics, and third one is different types of functions. So let us see logarithm, friends. See, what exactly a logarithm? Logarithm is nothing but a function. So logarithmic function can be defined here as log a to the base b equals to m. If at all log a to the base b is equal to m, then a equals to b power m. Right, friends? So this is what very important. So the value a is nothing but b power m. Next, the first property, log ab to the base c is equal to log a to the base c plus log b to the base c. There is a multiplication here, there is an addition here. Okay, friends? Log a by b to the base c equals to log a to the base c minus log b to the base c. There is a division here, there is a subtraction here. Right, next one, log a power m to the base b power n is equal to m by n log a to the base b. Log a to the base b is exactly here. These two powers came as division in front of the logarithm, right? So very important formula this is. Next one, log a to the base b, I can write it as 1 by log b to the base a. These two will interchange when it comes to denominator. Next, I can write this one as like this also, log a to the base c into log c to the base b. Here a is here and b is in the base itself, but these two, look at carefully. Okay, friends, later I can make this one as in this case like interchanging these two. Can I interchange these two by keeping it in the denominator, right? So log a to the base c divided by log b to the base c, right, friends? Next one, this is also important formula, important transformations, and a power x equals to, I can write it as e power log a power x to the base c. See, friends, logarithm and exponential functions are inverse to each other, so I can write this as, I can cancel these two and remaining is a power x. So here a power x is x comes in front of the log, so I can write this in this format also, e power x log a to the base e. Okay, next one, log a to the base c is always 1. When base is equal to this number, that value is nothing but 1, and log 1 to the any base is always 0. Next one, log 1 by a to the base a is minus log a to the base c. Okay, friends, generally we always say log to the base e is nothing but natural logarithm. Okay, friends, whenever there is a base e, then we say that it is a natural logarithm. Generally we always use in calculators the value of logarithm, that is nothing but with base 10. So when if he gives, suppose for example log 5 to the base 2, how we will find this value? This is nothing but log 5 to the base 10 divided by log 2 to the base 10. If we use in this formula, we will have the virtual calculators, right? In these virtual calculators we are available with this value. So whenever he asks any sort of value, suppose log 7 to the base 9, simple, friends, log 7 to the base 10 divided by log 9 to the base 10. So use this format, right, friends? So these are the important formulas of logarithms, so please note it down. Okay, so next one, that is nothing but trigonometry. Okay, now friends, let us see the basics of trigonometry. Probably you might have already learned in your 10th standard and inter standard. See, friends, once again let us revise. First one, sine theta is nothing but opposite side by hypotenuse, right? So in this right angle triangle, this is the angle that we need to measure, this is the opposite side, this is the adjacent side of the angle, and this is the hypotenuse which is opposite to 90 degrees. See, friends, this is the largest side. Okay, fine. So sine theta, what does sine explains? Sine is nothing but opposite side by hypotenuse, right? This is also inversely to 1 by cosecant. Next, cos theta is nothing but adjacent side by hypotenuse. This is inversely related to, cos theta is inversely related to secant theta. Next, tan theta is nothing but opposite side by adjacent side. So this is inverse. We can also write tan as sine by cos, and it is inversely related to 1 by cot. Right, friends? So these are the different values at different angles. So at 0 degrees sine 0 0, sine 30 1 by 2, sine 45 1 by root 2, sine 60 root 3 by 2, and sine 90 is 1. So now cos comes in reverse order. So 1 root 3 by 2, 1 by root 2, 1 by 2, and 0. Tan comes 0 by 1 is 0 because tan is nothing but sine by cos, right? So 0 by 1 is 0, 1 by 2 by root 3 by 2 is 1 by root 3. This division is nothing but 1. This division 2 can get cancelled, root 3 will come, and 1 by 0 is undefined, that is nothing but infinite. In this way you can write secant, cosecant, and cot also, friends. Okay, so there are completely 6 types of functions. So let us see the all silver teacups now. Just revise. This is a graph, and this is 0 degrees, this is up to 90 degrees. This quadrant 1 is nothing but 90 minus theta, and this is nothing but 90 minus theta, and next one after 90 degrees and before 180 degrees, this is 90 plus theta and 180 minus theta. After 180, this is 180 plus theta and 270 minus theta. Right friends? Later 270 plus theta, this one, and this is nothing but, we can also with completed of one rotation, this is 360 minus theta and this is 360 plus theta. In quadrant 1 friends, all 6 functions are positive, that is sine, cos, tan, cot, secant, cosecant, all these 6 functions are positive. Right friends? Nothing is negative here. Right? Now in silver only sine and cosecant, that's why SI means sine and its inverse cosecant are positive, remaining are negative, only these two are positive. Next one, tan means T means tan and cot, only these two are positive, remaining are negative. And cups starts with C, right? So cos and secant, these two are positive, remaining are negative. So in this way, I hope you already remember all these things. Once you look at these things, now let us see the formulas in trigonometry. Okay friends? Okay, friends, now let us see some few important formulas in trigonometry. First formula, these three, I think these three are called identities. These three are called identities, right? These three is called trigonometric identities, which are very important and you all know that, right? So sine squared theta plus cos squared theta is 1, cosecant squared theta minus cot squared theta is 1, secant squared theta minus tan squared theta is 1. Okay, next formula, see friends, sine of a plus or minus b. These are nothing but trigonometric transformations. See friends, sine of a plus or minus b is nothing but sine a cos b plus or minus, same plus or minus comes here when sine is applied, cos a sin b. Right friends? When a is equal to b, that's nothing but a plus b is a plus b is a plus a or b plus c is nothing but sine 2a, right? These are called multiple angles. So 2 sine a cos a. So sine of a plus b plus sine of a minus b gives 2 sine a cos b, and sine of a plus b minus sine of a minus b gives 2 cos a sin b friends. So these two are very important formulas. We often use these formulas in our calculus. Next, fifth formula, cos of a plus or minus b gives cos a cos b minus plus. Look at this friends. For cos, plus minus transform it into minus plus, and same functions repeats here and after. Right friends? Whereas in sine, same symbol comes but opposite functions will come. Right? Be careful. Next, when a is equal to b, cos 2a becomes cos square a minus sin square a, 1 minus 2 sin square a, 2 cos square a minus 1. These three are also very important formulas. We don't know at what particular time we need what particular formula. So learn these three also. Next, cos of a plus b plus cos of a minus b gives 2 cos a cos b, and cos of a minus b minus cos of a plus b gives 2 sin a sin b. Right friends? Next one, sixth formula, tan of a plus or minus b, it gives tan a plus or minus tan b by 1 minus plus tan a tan b. So at the upper side same comes, at the downer side opposite symbol comes. Right? Remember. Next, if put when a is equal to b, tan 2a is nothing but 2 tan a by 1 minus tan square a. This is also an important formula. You please remember these formulas friends. These formulas are very important for further to do the gate solved questions. Okay. Well, the next concept is slope of a line. Let us have some sort of, let us rewind the basics. See friends, what is the slope of a line friends? Suppose there is a curve I am having y equal to f of x. There is a straight line and this is the point of intersection. So how can I calculate the slope? It's nothing but if I know this angle, I can apply the tangent, right? So this is nothing but the tangent to this curve. So what is the slope friends? Tan theta. Tan theta is nothing but change of these two ordered pair, that is nothing but y2 minus y1 divided by x2 minus x1. This is nothing but dy by dx. Change in y with respect to change in x. When x changes, how much amount of y is changed? That is nothing but dy by dx. When x is changed, how much amount of y is changed is nothing but dy by dx, which is called derivative. Okay friends, derivative nothing is says nothing but slope, how much change the function is having with respect to x. Right friends? So x is the independent variable and y is called dependent variable. Okay friends, these two are very important concepts. And slope of the tangent of the curve of y equal to f of x at x1 y1, at this particular point x1 y1, what is the slope? That is nothing but first find dy by dx of this curve and substitute this point, then you will get the slope. Okay friends, so this is a very important basic concept. We will use it further. Okay friends. So next concept is function. So what is a function? function from set A to set B is a relation. This word is very important, friends. Relation from A to B satisfying the condition. To each element in A, there exists a unique element in B. This is a very important point. So suppose, let us take these three diagrams. So these two are sets, these two are sets, those two are sets also. So every element in A must be associated. Every element in A must be associated. Means the elements in A should never be alone. See friends, in this function, is that a function, friends? No, this is not, because this element is not associated with B other set. Right? Here all elements in this set is associated, and all in this set is also associated. So it must be associated with a unique element in B. It is also associated with some unique elements. Right friends? That is nothing but there is a relation between A and B. That relation is nothing but function F mapping A tends to B. We will be discussing the function in this mode. There is nothing but F mapping. There is a mapping here. There is a relation here. A tends to be from A. When we substitute, that is nothing but, suppose f of x is equal to y, or y equal to f of x. So when we substitute something in this function, we will get some function, right? That something x lies in A and the y gives the values in B. Right? So this is all about function, friends. So every element in A must be associated. Since there an element which is empty, this is not considered as a function, but these two are functions because every element in A is considered with the others. Right? So this is all about a function. Now let us see different types of functions. Okay, next one, types of functions. So the first type is explicit function. So friends, what do you mean by explicit function? See, for example, if we can say z equals to f of x1, x2, x3, so on, xn. If any function is in this format, it is called an explicit function, friends. See, here z is called dependent variable. Dependent variable. Okay, z is called dependent variable. Here, these are called independent variables. Independent variables. I already told you that x-axis is nothing but independent variable and y-axis is nothing but dependent variable, right? So, for example, y equal to x square minus 2x plus 2. This is an explicit function. So, y is different, x is different. Just look at that way. This is an explicit function. If at all implicit function, both xy's will be in one format is equal to some constant or 0. Right? This is implicit function. Okay friends, remember. Next, composite function in the sense, if at all z is a function such that it can be arranged with two x and y variables, where x is already a function of t and y is already a function of t, then z is a function of some other function. So that is nothing but composite function. Generally, we already saw these functions h circle f, g circle f in our intermediate, right? Those are nothing but composite functions, right? Which are already involved with some other functions. A function involved with some other functions. These are nothing but composite functions. For example, if z equal to x square plus y, x is nothing but t square plus 1 and y is nothing but 1 minus t. So these formats are called composite functions, friends. Okay, so there are three important types of functions: explicit, implicit and composite. Once you go through these three, okay. So let us see some special functions. First one is polynomial functions. What is a polynomial, friends? Poly means many. So polynomial in the sense, see, f of x equals to a0 plus a1x plus a2x square plus a3x cube plus so on until an x power n. This is called nth order polynomial. Okay friends, this is a polynomial and a0, a1, a2, a3, so on, an are called real numbers. These are real numbers such that an should never be equal to 0. That means the quotient should be 1 before x power n. That means the highest polynomial real number should never be 0. And this n should be equals to whole numbers. Okay friends, they starts from 0, right? So fine. Suppose let us take an example. F of x equal to 4x square plus 3x plus 2. This is the second order polynomial, second degree polynomial. Okay friends, this is also a quadratic equation. If suppose a polynomial of degree 0, it is called constant polynomial. What is the degree 0, friends? X power 0, right? X power 0 is nothing but 1. There will be a constant every time. So the polynomial of degree 0 is called a constant polynomial or simply a constant, right? So coming to next function, which is called rational function. If h of x and g of x are two polynomial functions, if there are two polynomial functions, then the function of the form f of x equals to h of x by g of x is called rational function, such that g of x should never be equal to 0. In the sense, nothing but a ratio. It is a ratio. A rational means ratio of two functions, which is in the form of f of x equal to like this, friends. This is called a rational function. So in this case, g of x should never be equal to 0, because if at all the denominator becomes 0, the function will be undefined, right? So condition that 3x square plus 2x plus 2, this should never be equal to 0. In such cases, these functions are called rational functions, right? Next one, friends, algebraic function. See, if a relation arises due to performing a finite number of fundamental operations, that is addition, subtraction, etc., that is multiplication, division as well, on polynomial functions, then such a relation is called an algebraic function. See, for example, 2x square plus 3x plus 2. Until this is a polynomial functions of degree 2. At the same time, there is a multiplication with other function, root over x square plus 1. This is an algebraic function, friends, because there is another operation performed, that is multiplication operation has been performed on a polynomial function, right? Suppose all polynomial functions are algebraic. This is very important note. All polynomial functions, the function which we have discussed earlier in the second one, polynomial functions, they are all algebraic. Until here, this is both polynomial and algebraic function. Here, this is not polynomial now, this is now algebraic, right? So, but not the converse. A function that is not algebraic is called transcendental function. Suppose, if this is a particular algebraic function, suppose if I will say sin x plus x square minus 2. This function, this is not an algebraic function, friends, because sin is involved, therefore it is called transcendental function, right? So whenever these trigonometric functions or exponential functions or logarithmic functions involved in any algebraic function, they will turn as transcendental functions, right? So this is very important, please once check it. Now let us see, friends, fourth one, even function. When a function is said to be an even function, friends, the condition is f of minus x is equal to f of x, right? So for example, take cos x. This cos function is an even function. Modulus function, I will tell you what modulus function is. An even powers of a polynomial. This is nothing but an even function, friends. Whenever this follows, f of minus x equal to f of x. For example, if I could say, suppose take x square. If f of x equal to x square, f of minus 2, what is the value? Minus 2 whole square, that is nothing but 4. What is f of 2? That is also nothing but 4, right? Both f of minus 2 and f of 2 are equal. That's why f of minus x and f of x are equal in this function. So these particular functions are called even functions. And odd functions, if at all, if it is not equal to f of x and it is equal to minus f of x, it is called odd functions. For example, sine is an odd function, and x power 1, x power 3, x power 5, x power 7, x power 9, odd powers of x is nothing but odd functions, right, friends? Next, logarithmic functions. Friends, listen it carefully. If at all, f of x equal to log x to the base a. Remember, friends, a should never become negative. Base is always greater than 0. Okay, so take it as granted. So a comma x belongs to R. A and x are real numbers, and a should be greater than 0, and a is not equal to 1. Base should never become equal to 1, and a should be greater than 0. These basics you are already learned in your intermediate. So it's called logarithmic function. And f of x, see friends, if base is greater than 1, the curve will be increasing order, and at particular 1 value it becomes 0. Log 1 is always 0, friends. If base is from 0 to 1, then curve will be in decreasing order, and log 1 is always equal to 0, friends. That's why it is cutting the value at 1. That's why log 1 is equal to 0. So these two are important graphs. Please do remember. And once you always verify even and odd functions in different sorts of functions. Okay. Okay. Friends, now exponential function. What do you mean by exponential function? A function of the form f of x equal to a power x equals to e power x log a to the base e. I already told in logarithmics, in basics of logarithms, we can perform a power x into as e power x log a to the base e. So this is nothing but, see, x I can take it here, right? And e and log e to the log to the base e is nothing but inverse functions. Both get cancelled, and I can get a power x. So a is always greater than 0. A should never be negative, and a is always not equal to 1 and it should be not equal to 1. If it is 1, the final value will be 1, right? So not equal to 1, and x belongs to real numbers. This power belongs to real number set. It is called an exponential function, friends. And the graph is, if a is equals to 1, is greater than 1, if a is greater than 1, the graph will be in increasing order, and if a is 0 to in between 0 and 1, the graph will be in decreasing order. This is the exponential function, friends. E power x or a power x, right? So of order, right? Did you understand? So remember, friends, a should be always greater than 0. If a is greater than 1, the graph will be increasing, and if a is in between 0 and 1, graph will be decreasing. Okay. Now let us see another important function. Listen carefully, friends. This function is very, very important. So many questions are framed in GATE exam basing on this function. See, this is a modulus function. A function of the form f of x equals to mod x is nothing but a modulus function, or this is also called as absolute value function. See, the format is, for example, if x is greater than 0, that is if x is positive, the values are positive, the x-axis after 0, if this value x is positive, then it has plus x. That means the slope is positive, and that means increasing function is there. Linearly increasing function. If x is less than 0, that is x is negative, that this one, the slope is negative, that is minus x. At x equals to 0, the value is 0. Look at the diagram, friends. At x equal to 0, it is 0. For x greater than 0, for x greater than 0, the value is increasing, that is positive x, and for less than 0, the function is minus x, that is decreasing less than 0, right? So this is the figure for mod x, friends. And remember, these positive and negative are nothing but slopes. Mod x is a continuous function. At any perspective, there is no any sort of discontinuity, friends, no breaks at all, right? So this is a continuous function for every x belongs to R. Infinite case, it is go on. We will get the continuous value, we will get the finite value, but at infinity we will get infinite. That's another topic. Modulus x is not differentiable at x is equal to 0, but at x equal to 0, this function is not differentiable. I will be telling you what differentiability is. Until then, hold on. See, modulus x is not differential. Remember, whenever there is a sharp cone, whenever there is a sharp cone in the graph, at that particular point, see, friends, here there is a sharp cone, right? At this particular point, the function is not differentiable. Remember. Next, modulus x plus a is not differentiable at x equal to minus a, and mod x minus a is not differentiable at x is equal to a. What does it mean? See, friends, mod x plus a, in the sense x equal to minus a, it becomes 0. X equal to minus a, this becomes 0. So at this particular point, at x equal to minus a, the function is not differentiable. And if suppose this is a, right, this is nothing but mod x minus a, right, friends, mod x minus a. So at this particular a, this value, function is not differentiable, but it is continuous at every perspective, every point of time, but it is not continuous whenever there is a sharp cone, at wherever there is a sharp cone, right? So this function is very important. We will also discuss a lot of problems regarding modulus function. Okay, friends. Now, next function. So next important function, friends, signum function. See, friends, f of x equal to signum of x, that is nothing but sgn of x. This is called signum function. See, the format of this function is in this way. At particular 0, its value is 0. At 0 plus, that means initial right side position of x, it jumps to plus 1. So it is all positive for all positive real numbers. It is negative for all negative real numbers. That's why we say mod x divided by x, modulus function divided by x for all x not equal to 0 and 0 for x equal to 0. See, friends, for x greater than 0, the value is plus 1. The x equal to 0, the value is 0. For x less than 0, the value is minus 1. Right, friends? So what we need to understand here, there is a particular discontinuity is there at particular point 0. At particular point 0, generally we wrote because by taking the average of these two values, but we cannot say the exact value since here there is a jump discontinuity. So this is a discontinuity, we cannot tell the exact value. So we will say the limit of this particular function. I will be discussing this function again when I teach you limits. See, here there is a discontinuity, hence we cannot say the limit of this function at x tends to 0. So this is a very important function, friends. Just check it once. So next important function is step function or bracket function or greatest integer function. Remember friends, so a function of the form, this is the format f of x equal to bracket x such that n less than or equals to x less than n plus 1. See friends, suppose n equal to 3 and this is n plus 1 is nothing but 4, right? Let us suppose. That means if the function is lying between 3 and 4, what does it is saying? N is less than or equal to 3 but not equal to 4. That means whenever the function is in between 3 and 4, if suppose that is 3.2, it tends to 3 only. It never goes to 4. So we have to take 3 is the integer value. In that case, every decimal will turn to an integer, lowest integer, right? See friends, if suppose this is 1.2, we have to take only 1. It never goes to 2, right? This is the case. If suppose this is minus 1.2, we have to take minus 2 because it is going left side. That is the important case in this. So bracket 7.2 gives 7, that is nothing but if suppose, see friends here, 6, 7, right? If suppose 7 is there, 7.2 here. So it tends to like this. Then means what is the immediate integer? 7 is the immediate integer. So bracket 7.2 is nothing but 7. Bracket integer is always an integer, that is nothing but 7 only. Minus 1.2, bracket minus 1.2, you already discussed it, right? It tends to here, that means minus 2 is the integer, so minus 2 is the one. Bracket 0 is always 0, 0 is also an integer. And if x equal to minus 1, suppose if x equal to minus 1, what is the range friends? Minus 1 less than or equal to, according to this one, here equal to will come, here equal to won't comes. So minus 1 less than or equal to x less than minus 1 plus 1 is nothing but 0. In this case, we perform all these values, and remember, step function is discontinuous, where at every integer point, it is discontinuous friends. So there is no value, we cannot say the value. There is a discontinuity here, there is a jump here, there is a discontinuity here. So step function is discontinuous at every integer point. Remember this point, not at all points, at every integer point only it is discontinuous. Hope you understand. Now let us see symmetrical properties of a curve. Okay friends, see friends, if the equation of the curve contains only even powers of x, that is f of minus x comma y equals to f of xy, y is symmetrical, right? Then it is symmetric about y axis. If at all y is symmetrical of y axis, when we close this one, this curve should touch this curve. That is nothing but x square equal to 4y. This curve is the equation. So in order to be symmetrical, it has to follow this condition. If f of minus x comma y equal to f of x comma y should never have a negative sign, only x will have the negative sign friends. So this is the case. When we close this y axis, when we fold the y axis, this curve should meet this curve. Then it is called even powers of x, and it is symmetric about y axis. If it is symmetric about x axis, we will fold like this friends. Then this curve will touch this curve, and y square equal to 4ax is the equation of this curve, and it is even powers of y. So what is the condition friends here? Here x should be equal, y should be negative, right? Here y is equal, x should be negative. Remember these two curves. These are the symmetrical properties. Now let us see the other curve. Now see this curve friends. See, this is both symmetrical to y equal to x line. This is y equal to x. See friends, f of x comma y equal to f of y comma x, then it is symmetric about the line y equals to x. This is the line y equal to mx. See, y equals to mx plus c we have seen. Y equal to mx means m is the slope, right? This is the straight line. This is y is mx line. Now when we close this curve, this will touch this one, right? This is nothing but symmetrical to y equal to x line. So this is also one of the type, and in this case f of xy will be equal to f of yx friends. So there is no negative symbol here. This is symmetric about y equal to x line. These are the symmetrical properties of